Hello, this is Delisa Garcia, and this is a video tutorial on how to use the semi-automatic tools of FilamentTracer to reconstruct dendrites. Our objectives are to learn how to segment dendrites using the AutoPath algorithm and how to use the automatic functions of FilamentTracer to segment automatically the spines of such dendrites. For this, I want to acknowledge Lilian Enriquez Barreto from the Institute of Neuroscience at the Universitat Autònoma de Barcelona, who kindly provided the dataset for this video tutorial. So let's start opening Lilian's image in Imaris. First of all, what we need to do is to add a new filament. We will skip the automatic creation and in this case select the AutoPath algorithm method in order to draw the dendrites of interest. For this, place your pointer in the select mode. Next, press the shortcut Shift, right-click at the beginning of the dendrite so that the algorithm starts quantifying a starting point. When it finishes, a fast marching algorithm will start. Okay, now we can move our cursor from the beginning to the end of the dendrite. Once we have reached the end of the dendrite, we will click Shift and left click in order to specify the end of the dendrite. Again, I press Shift, left click to specify the end of the dendrite. Now we have the first dendrites drawn. If I want to define a new dendrite, for example this one that runs at a deeper Z plane, what I can do is again press Shift, right click to specify a new starting point. Again, let the algorithm finish. And once it is finished, we will be able to define the path of this second dendrite. Shift left click to specify the end, like so. Now we need to segment the spines of all these dendrites. To do it manually, it will be quite time consuming. So what we can do is to use the automatic tools of FilamentTracer in order to detect the spines. For this, we click in the Creation tab, and in the Rebuild options, we will choose Rebuild Dendrite Diameter and click Rebuild. This will help us to first adjust the signal thresholds for the detection of the dendrites so we can have a good quantification of the diameter of the dendrites. Do not worry if we have also some signal in these other dendrites, but because they were not drawn previously, they will not be segmented now. Select the algorithm you want to choose to quantify the diameter. In this case, I will choose the shortest distance from distance map. And in the next step, we will go into the detection of the spines. First, we need to specify the seed points, or as indicated here, the thinnest diameter of spine head, for example. So we can go into the slice mode. I zoom in and I can measure, for example, some of the smallest spines around 0.28 microns. You can move to different set positions and measure a few spine heads. So I'm going to use 0.28 as I measured earlier. Click into 3D view, 0.28, and now we have to enter what is the maximum length of a spine. Again, click in slice, and we can measure the length of some of the spines from the middle of the trunk of the dendrite to the end of the spine. We can measure different ones to have an idea of how long the spines can be. So in this case, I'm measuring a few of around pretty close to 2 microns or 1.5 microns. So let's choose the longest distance, in this case 2 microns. So I will enter a maximum length of 2 microns. Going to the next step, and this blue seeds represents the spine heads. So what is happening here is that we have some seeds that these ones do not really correspond to spines from the dendrite, but to another dendrite that is crossing over. So if we don't want this to be segmented as spine, we can delete them. For this, place your pointer in the select mode and press Shift left click on top of these little blue seeds. Remember that we specify a maximum length of a spine of 2 microns. Therefore, in the meantime, we don't have seeds in the length of 2 microns. We will be in good terms in order to not to detect in this area an spine. Something like this. Perfect. If we are missing, for example, a low signal spine, this is also your time to add it. In the same way we use the shortcut Shift left click to remove a spine, we can use the shortcut Shift left click to add a seed point. Okay, now we can continue. And in the next step, the same that we did for the calculation of the diameter of the dendrites in the previous step. Now we come into the step where we have to quantify the diameter of the spines. For that, again, we will adjust the thresholds to the right intensity signals and choose the algorithm that will be used in order to quantify the diameter for the spines. In this case, I will choose the shortest distance from distance map. Since there are no more next steps, let's finish the algorithm. And now we have the dendrites segmented with the corresponding spines. All the statistics can be found in the Statistics tab under Overall and Detail. I hope you have enjoyed this video tutorial. More information can be found in the Learning Center. And any questions you may have, do not hesitate to send me an email. Thank you for watching this video. Bye for now.